Hello, we are going to start graphing functions. Among these functions, we are going to deal with rational functions. As we know, rational functions involve asymptotes more often than not. We need to know how to find the asymptotes of a function in order to be able to sketch it properly, as we will see in the next lesson. But to begin, if you have a function f of x of this form 1 over x minus a, where x cannot be a, because we cannot have 0 in the denominator, then we know that the equation x equal a, it's a vertical asymptote for our function. We're going to denote that with VA in short. Not all functions look just as simple as this one, so we need a general formula to calculate a vertical asymptote. We already know how to calculate a limit, therefore we're going to use limits this time in order to calculate a vertical asymptote for any type of function. We will use the following criteria. The vertical asymptote x equal a is the vertical asymptote for a function f of x if the limit when x approaches a of f of x is plus or minus infinity. A very quick and easy way to determine a vertical asymptote for a function is to look at the denominator of that function and find all the values for which the denominator becomes 0. Horizontal asymptotes can be found based on this general rule. We say that y equals a is a horizontal asymptote if limit of f of x when x approaches infinity is a, or limit of f of x when x approaches minus infinity is a. So that y equals a is going to be your horizontal asymptote. I know, however, that most students just don't like to calculate limits. Therefore, I'm going to provide you a little help for determining if a function has a horizontal asymptote and a way to find that horizontal asymptote. So consider a function f of x described by this fraction. So you're going to have an x at power n plus a minus 1 x at power n minus 1 and so forth all the way to a1x plus a0, everything over bm x at power m plus bm minus 1 x at power m minus 1 and so forth b1x plus b0, where an and bm are different than 0. So basically you have two polynomial expressions in the numerator and the denominator. Analyzing the degrees of these polynomials, we can determine if our rational function has a horizontal asymptote. So if the degree of the numerator is less than the degree of the denominator, we can conclude that the x-axis is the horizontal asymptote for our function. If n equals m, so both denominator and numerator have the same degree, then we have a horizontal asymptote, and that is y equals an over bm. So basically we only keep the coefficients of the terms with the highest degree in both numerator and denominator. If the degree of the numerator is actually greater than the degree of the denominator, then we don't have a horizontal asymptote for f of x. However, we know that we're going to have an oblique asymptote in this case. And with this we go to the last type of asymptotes that we're going to encounter. The oblique asymptotes are those that are not parallel to x-axis or y-axis. As I said earlier, you're going to have such an asymptote, an oblique asymptote, only when the degree of the numerator is greater than the degree of the denominator. In order to obtain the oblique asymptote, you have to perform the long division between the numerator and the denominator. And the equation for your oblique asymptote is going to be given by the polynomial part of the quotient of this division. I'm gonna make some examples, so hopefully it's not that difficult. It's not gonna be so difficult for you to determine it. Thanks for watching.